Okay, so in the previous class we have done this 4 and 9. Let us now go to 10, then 19, then question 10. Let us do that. Let me read the question for us. An object of mass 40 kg. So here, let us start here. M is equal to 40 kg is the mass. Raised to a height means height above ground, 5 meter is the height above ground, okay, above the ground. What is the potential energy? So let us just put your EP, question mark is the potential energy involved. If the object is allowed to fall, okay, that part we can do, second part. You know, potential energy formula is mgh. Already have this, so we need this h also there. So let's write for g. When g is not given, we must use 9.8 meter per second square ourselves if it's not given in question. If it's given in question, we must use that. But here in this case, when we check the book answer, they are not using this, they are using 10 meter per second square. So let's just use the same according to the textbook answer. Acceleration due to gravity, okay. Let's go about it slowly so we get it properly. Then here, therefore, since we know by formula, any object raised above ground is potential energy, which is EP here. Formula is mgh, right? So let us write here m is 40 kg, g is 10 meter per second square, as we can see here, m 40 kg, and h height is 5 meter, right? So 5 4s are 20, then still 1 2 0 left, so 2, and here kg, then this one meter per second square, and here another meter. Okay, so here that will give you 2000, and we know kg meter per second square is the best unit of force, which is can be written in short as Newton, and here m. Newton meter, which is the unit of energy, okay, can be written in short in the SI unit joule, right, in the honor of the scientist joule. So this is our first answer. Then we have to calculate the kinetic energy halfway down. So let us write here EK equal to question mark is equal to kinetic energy halfway. So that means the object is here, 40 kg object, and then it is at a height of, this is the ground. If you want to draw, then 5 meter. So halfway means the object is here. So this is halfway. So at halfway, the distance traveled will be total height, which is 5 divided by 2, which is 5 divided by 2 meter, 2.5 meter. It is distance covered halfway, as we can explain, we have explained in the diagram here. At halfway it will be total height by 2, right? So S will be like that. And since kinetic energy formula is half mv square, we need v square. So v, let us write question mark, is velocity at halfway. Exactly at halfway it would have been gaining a velocity, right? So let us do that. Now since the object is falling down, it will have acceleration, and since it is falling in the same direction as gravity, it will be plus. However, the object that is dropped 10 meter per second square opposite to here, using this, because for an object that is dropped, A is positive. For an object that is thrown up, since it is moving against gravity, it will be minus, okay? So this is acceleration of the object. So you can simply write acceleration. So next here, U will be for an object that is dropped. You see here, before you drop this ball from the height, it's not moving, means initial velocity will be, initially it was not moving, means 0. But if you throw this ball up, so initially it was moving, but when it comes to the tallest height at 5 meter, it will stop. That means final velocity for object thrown up is 0. Think about it. But for an object drop, initially it was not held and not moving, so u will be 0. For an object thrown up, it will stop at the highest height, so that its final velocity will be 0. So here thrown downward, so 0, because you can see here downward. Okay, this is plus u right here. The reason is since downward fall, that's why a will be plus. Here u is 0 because of the same reason, downward fall. Get these things clearly, okay? So next here, once we are through with that, we have to calculate the kinetic energy. But before that, we have see here half mv square means we have m 40 kg, but we don't have v square. This is the question mark. So how can we get? In this case, we have to manipulate 2as is equal to v square minus. This is the famous equation from motion. So if you do that, then we are going to get here v square don't move, 2as also don't move, and you shift this minus u square to the right left side and become plus u square equal to 0. So same place, shift this one. So v square we can now calculate. We can bring it this side if you want. No, also it's okay. You can do it from the left also. A is just now here 10 meter per second square, right? And S is here, as you can see, into 2.5 meter. And plus u square, so plus 0 meter per second, whole thing square because this is v square. U square, sorry. So that will give you equal to 2 tens are. Okay, let us use this to this. And 1 0 means decimal move to the right side of 5, so 25. 25 2s are 50 meter into meter, meter square, and then here second to the power minus 2. This 0 will disappear because 0 will multiply these units, and even the units will disappear, so that is finished. Oh, that is not there anymore. If you want, put it as 1. Then let's continue. So kinetic energy halfway down, which you have put EK. This formula for kinetic energy is mv square, half mv square, sorry. To be exact, half into m is 40 kg. Into v square is here, this one. 50 meter square per second square. So here 2 2s are 4 0. Then 5 2s are 10. 1 2 more 0. Then here let's write kg. Let's break this meter square and show meter meter. Then let us take this kg meter. Let's take this per second square. And this one not yet taken. At the back we put it. Then this is going to give you 1000 kg meter per second is square is the base unit of force, Newton meter. So 1000 joules. So this is the kinetic energy halfway down, and the potential energy at the maximum height of 5 meter is 2000 joules. So those are the two answers, 2000 and kinetic energy halfway 1000 joules. Okay, one more question before we complete this part, which is 19. So let's go to 19. After that we can give our test. Okay, so here let's go about doing it slowly. Number 19. So here it takes 20 seconds for A to climb up a stair while B does the same height climbing on the stair 15 seconds. Compare the work done and power developed by A and B. So let H be the height. Let H be the height of the staircase that both of them have climbed to the same height. Okay, then they have a mass, so let us put that. Let MA and MB be the masses of the two persons of A and B respectively. Okay, now work done by A. Let us calculate. Work done by the person A. Let us put the blue A equal to Since it's climbing above the climbing the height will be potential energy, which is mass of A ma, G, and the height h. So this is the work done by A. Similarly, work done by B, which is WB, let us say. I'm using these terms, okay, to make it shorter. Work done by B will be similarly mass of B, which is MB. Acceleration is same, G, height is the same, height the climb. So let's write down here. First question is saying there, look there, compare the work done. So compare means ratio. So ratio of work done by these two persons. When you compare the work done by two different persons, that is called ratio. Ratio means division. So the work done by A divided by work done by B, that is called ratio. And ratio means comparing means ratio. Simple as that. So WA is here MA GH divided by WB is MB GH, as you can see. So these two can cancel, GH. So the first answer is MA divided by MB, or in the ratio language also you can write MA is to MB, first answer. So either style of writing, it's up to you. Okay. Then let us see there now, power developed by A. So let us write down. We have to compare the power next. Work done, compare. So let's do singly first. Power developed by A. Let us put here PA. Okay, P capital A, let us say. The person A. Now power is work done by A divided by time taken by him. So WA we already found out here. So MA GH by time taken by A. Go to question. A climbs, B does. It takes 20 seconds for A. So time for A is 20 seconds. So let's just keep it like that. And here power developed by B, PB, power developed by B, PB will be WB is likewise by time taken by B. So WB is here, as you can see, MBGH. So let's write there MBGH divided by time taken by B. Go to question. It takes 20 seconds for A to climb up, while B does the same in 15 seconds. So time taken by B is 15 seconds. So let us write down here. Final answer. That is the ratio of power developed. Compare the power developed means ratio. So ratio of power developed by these two persons. Write it down. Will be equal to power developed by A, PA, by power developed by B, PB. As you can see here, PA and PB. Dividing means ratio, and ratio means comparing also. So PA is, as you can see there, PA MAGH divided by 20 seconds, and this line should be longer, okay? And the equal sign should be there in the longer line. And then PB is here, MBGH divided by MAGH, write it properly, MAGH, 15 seconds, as you can see here. So slowly do this, and just a matter of doing it patiently and carefully, not hard. So this part here we can write MAGH by 20 seconds, and division sign change to multiplication sign, then down 15 seconds will go up, and up MB, this G numerator, and H, this will come down, and this denominator will go up when you change this division sign into multiplication sign. I hope you're getting. Second and second cancels, GH cancels, 5 3s are 15, 5 4s are 20, 3 into MA is 3 MA divided by here 4 into MB is 4 MB. So the answer is comparison is 3 MA2 divided by 4 MB. That's your answer. Or you can also write 3 MA in the ratio language is to 4 MB, which is up to you, right? So that's how we do. I hope you got it. Now you can go and give the test.